Hello everyone, this is Kinkun IoT. This video I will show you this relay board. This is KC868A8. It have 8 channel relay output and 8 channel relay input, and work with this ESP32 module. This video I will show you how to extend the GPIO port for ESP32. The ESP32 is more popular in market, used by many DIY, but it have a little GPIO port, so that we have 8 channel output and 8 channel input. There is not enough GPIO to use, so we need to extend. This video I will show you how to extend and how to use Arduino IDE to drive this output for relay on and off. This have 2 chips. This is PCF8574 the IIC chip. This one chip is 8 channel for this input, and this chip is for this 8 channel output. This is all use IIC chip. You can see this is for extend. If you have many IIC device, you can extend by this SCL and SDA, and this is VCC and ground, and this SCL is clock, and this SDA is date. So the IIC chip have this 2 signal and the clock and the power and the ground. So you can extend for many chips. If not enough for 8 channel for your use, and you can extend for many different IIC chip. Just connect SCL and SDA together. Also, you can extend for LCD display or LED display. Just use the IIC chip, IIC bus. So now we can use this board. Take example for tell you to how to drive this relay output. You can see this is our A8 board. This A8 board have this pin defined and in this diagram, and also we have the pin defined in this form. You can click and see the details of every pin, which is IIC, SDA, and SCL defined, and the relay output and the input, and the temperature sensor, and the digital input, and the wireless receiver, and the Ethernet port. So this all have listed the I/O pin. But also you can in this our website document and find out the A8 diagram details. You can see this. Just click and you will see the photo, and every define you can find in this diagram. And now we began to tell you how to use this relay output on and off. And also we can use this Arduino IDE. This Arduino IDE we have write this demo code, and this code I will upload to our form. You can download and use it directly. And before to use, you can see this relay is not use the GPIO directly, so we have used this PCF chip to extend the GPIO. We can just see this diagram, and you can see this is PCF8574. This is for input. This is in, it means input channel, and this is output channel. And this is for output, and you can see the output is connected. This is a relay driver, and this is 8 channel relay output. So we can see the command is connected with this chip with the ESP32, and you can see the SDA and SCL have connected with this 2 line. And this also have the SDA and SCL. So if you have many chips, because the A1, A0, A2, we have 3 lines work as the address. So we have many devices we can connect together. This is for output. This have the SDA and SCL. This A0, A1, A2, you can see this photo. this is for output. So they have connected with the same SDA and SCL. But for this chip, you can see this A0 is 0, A1 is 0, and A2 is 1. So you can see this is 0, 0, 1. So this is 24. This address is 24. So we can see our Arduino code. You can see this is defines the output, and we can see this is 24. This is 24. And the input, if next video I will tell you how to use the input port. The input is this one, and 0, 1, 0. So that's 0, 1, 0. So this is for input. Just a 22 address is for input. So now we have see this output. So we can see this Arduino code. You can include this Arduino.h and this PCF8574.h. This you need to install the library. We can see the online library management, and we just import this PCF8574, and I can choose. I have installed. You can see this library you need to install. I have installed. You just install online. Just click this button, and will complete the install. And I choose close. And after you install, we can go on. And this is define the address. This is 24. I have tell you why is 24. And this began with the serial port. And you can define this pin mode. Just set the P0 until P7. That is relay 1, relay 2, relay 3, relay 4, until relay 8. That is defined for output because we want to turn on and turn off the relay. And this is display, print the information. If initials, the IIC is OK, just print OK. If it is false, just print KO. KO is not OK. So this began to loop. Loop we just set the default is low. Every channel, 8 channel is low, so we can at first to turn off our relay and delay about 3 seconds, and we began to turn on every relay. This is relay high means on, so this relay 1 is on, relay 2 is on, and relay 3 is on, and after every 300 milliseconds will be relay on, and until relay 8 is on, we just turn off every relay from relay 8 to relay 1, just off, 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 off. Also, every delay time is 300 milliseconds. And this code is very easy. Just not use this GPIO directly. We have used this PCF to extend the GPIO. So we just, before the GPIO words, we just use this PCF8574 dot digital write, and also dot pin mode to set the output or input. Now we can download it. We can see the result. We just upload. Before it's complete, I will tell you, because when you use IIC chip, you need to define. I have used the Node MCU 32S because I have used this 32S. So you need to find out this pin Arduino.h. This at this path very long. You just can according to my path, and you will find this file, and open this file, and then you need to define this SDA and SCL. This date and clock, this is very important. Don't remember to change this pin. You need to change this pin because we can see this is IIC, SDA, and SCL. is as seen as this 4 and 5. Okay, now let's power on. I will power on, and the USB is detected. I can click upload again. Now it began download. Okay, you can see the relay all is on, and now began to turn on after every 300 milliseconds, and also it turn off at every 300 milliseconds. So this is the relay output, and this is LED indicate for 1, 2, 3, 4, and 5, 6, 7, 8. And now you can see the code is running, and turn on and turn off the relay output. Okay, this is how to use the Arduino IDE to control the GPIO extended by the IIC chip. Thanks for watching.